All right, now we're going to talk a little bit about compound events. So compound events are when you want one or more things, when you want more than one thing to happen. Like, so it's like, what's the likelihood of this happening and this happening, right? Um, pretty much we're usually looking at and situations. Ors are a little different, but we're going to look pretty much at and. And so we have independent events. So an independent event means that they don't relate to each other, like they have nothing to do with each other. So like a classic way of thinking about an independent event is it versus dependent is if you have a bag of marbles, right? And you say, okay, I'm gonna see what's the probability of me picking out a red marble, all right, out of all the different colors that are in there. And then you would calculate that, and then you would put the marble back, and you say, what's the probability of me picking out a red marble again? All right. So you would, they aren't necessarily related to each other. All right. You want them in a certain order, but they're not related. One doesn't influence the other. Now, if I said the first time, what's the probability of picking out a red marble and then not replacing it, and then the probability of picking out another red marble, that would change it because you've got one less red marble in there if you got what you wanted on the first draw. So it does impact it depending if it's independent or dependent. And so in this vid, we're going to talk mostly about independent events, right? And so this is where one doesn't have an effect on the other. And what it says here is if two events A and B are independent, then the probability of doing both of them is you basically find the probability individually of them and then you multiply them together. All right, that's what P of A times P of B means. P of A and B, you just multiply them together. So let's look at this example, and then I think this will be kind of clear. The robotics club at a high school sells 150 raffle tickets. So you've got 150 raffle tickets for Amazon, right? And then you've got 200 raffle tickets for movie night, right? Movie nights. Okay, so Amazon and movie night, right? And it says Mackenzie bought 5 for each. So she bought 5 raffle tickets for Amazon. She bought 5 raffle tickets for movie night, right? What's the probability that he wins both? All right, I might have said she. Sorry, I'm used to hearing that as a female name, but we'll just say they. So they do that, right? Then what we'll do, what we're looking at is they got a 5 in 150 chance that they're going to win the Amazon. And then the movie night, which is not related, they have a 5 in 200 chance, right? And so what we're going to do is we're going to multiply those together. Now, before we do that, I'm going to make this a little easier on myself, and I'm going to divide, right? So this becomes 5 goes into itself once, 5 goes into 150 30 times, right? So we'll make that 130. 5 goes into 20 40 times, and it goes into itself once, right? And so we'll go 1 over 30 times 1 over 40, which gives you 1 over, well, 3 times 4 is 12. And then tack your zeros on 1 and 1200, which is, to put this in perspective, 0.0008. All right? And so if we figure this out, right, you move your thing here, you have a 0.08% chance of winning both, right? Winning both. All right, so not likely. not likely at all. You have less than 0.1% chance of winning that, okay? But I mean that's, hey man, that's how it goes. I'm gonna make sure I did that right. Yeah, I did it right. Okay, so hopefully that kind of makes sense. You just kind of multiply them together, right? You figure out what one is, figure out what the other is, and you multiply them. And that is when they are independent of each other. All right. So thanks for watching. Next video, we'll talk about dependent events.